I'm Herve Javice from ioTech. Today we have a special offer. You get two presenters for the price of one. So I'll introduce the company, the technology, and then Stéphane Etienne will present the applications.
Well, we can do Cotema also.
We can present Cotema. No. Thank you very much for a great presentation. So the ioTech, we're in the business of deposition. We are basically high resolution, deposition for any kind of fluid material. So whether it could be conductive or dielectrics. Okay, this is our research center. We have been in existence. We started the company 9 years ago. And what we are doing is we are enabling miniaturization, novel designs, and these are critical aspects for the world of mobility, big data, and AI. And what we're offering is something very simple. It's using the current materials you are interested in, you are printing, and offering a better resolution. So the issue in the market was the fact that there is a need, especially in the packaging, for instance, but also in print electronics, to go smaller. And there is a need for cleaner and more flexible. These are what we are responding to. So what we're offering is same material, better deposition. It's digital, it's high resolution. This is higher accuracy, industrial speed, and lower cost of ownership. The way it works is basically we're using a laser for the deposition. So we have here any kind of material you want to put in this dispenser. The material will flow onto this foil. For those who can remember that, the old VHS tape. Here it's a PET with a special formula on coating. Then, and I think if you take a second time, we'll probably see it on the, you see here the material that flows and comes in front of a laser. And this is this laser, which is going to push the material down onto the substrate. And what you get is basically the ability to print any material, any viscosity. And I think that's important because inkjet is an amazing technology, but it requires fairly liquid materials. What we can do is take materials which are anywhere between, let's say, 500 centipars and 500,000 centipars. So we can deposit pretty much any material. And we are able to do field materials. We can do high resolution, high speed, multi-layers, which is also very important. Multi-material. You can have 4 materials at the same time. And it's non-contact. And there is no mechanical parts. And this is the big difference. Because if you look at screen printer, they have a screen, they have a stencil. If you look at a dispensing machine, it has a valve, it has a nozzle. And this is what limits the miniaturization and what limits the accuracy. So here, just a bit more, you have the liquid material here, and you have basically the laser, which is going to create this push towards the dispensing, and this is happening like 1,000, 2,000 times per second. So it's very quick. And as you see here, we can have viscosities which are like 3,000 times higher than what's possible with inkjet. What we have in our machine as well, which can be useful in all the process development and in some production instances, is we have the curing, which is available, which is either the UV curing or the heat curing. And we have a laser. So we can use the laser for other things. And one is laser sintering, which is possible. Also, typically we're going to go for a resolution that can go up to, let's say, 40 micron. Let's imagine you need something even thinner. We can even do ablation. We can do ablation. The importance of basically sustainability is that we are not using any acid. It's an additive process, not subtractive.